Hello there. Today we'll be doing coin change. This is a very interesting problem with many solutions, and we're going to be going over many of these solutions. Well, not many, but three. First, we're going to go through in this video the top-down approach using memorization. Then we're going to do the bottom-up approach, and then we're going to do the BFS approach. So this is going to be three videos, number 99. So what we're trying to do here is to learn as much as possible rather than to get through as many problems as possible. There's so much to learn here. In this particular problem, we have coins. We have three separate coins here and the amount. And we're trying to find out how many ways, minimum amount of coins that we can get to 11. Breadth first search is a way to get there because we're going to search through each level until we get to the closest level at which we finish our search. That eliminates many of the possibilities. But what we're going to do first is you're going to do dynamic programming. Well, the reason why we're going to choose to do dynamic programming is because greedy doesn't work. The greedy approach does not work because if we suppose we had a 1, a 4, and let's say a 9, and we're trying to get 12. It will take three fours to get to 12, but if you started at 9, and you would need 3 1s to get to 12. So that is the reason why greedy approach does not work. We need to use a backtracking approach where we can look at 1, 4, 9. 1, 4, and 9. So for every item, we look at every other item, and we find out, okay, so with 1, 4, and 9, and 4, 1, 4, and 9, and 9, and 1, 4, and 9, what are the ways to get to our solution? Our solution, if it gets past like 18 minus 12, 12 minus 18, if it's gone past that, let's set that to infinite, because that means it's not possible. The coins is just, we can't get there. We're trying to get the minimum number of coins. So by using a max, like a max infinite, that will never be a very good item to choose. So with that item, we're going to look at let's say we tried a 4, and we see an 8 here. We see a 4 plus 4, which is 12 minus 8. 8 minus 12. 12 minus 8. 12 minus 8, and that is equal to 4. And another 4 would result in our answer here. So as you can see, we're looking at this problem until it gets down to 0. So we get 12 minus 12, which is equal to 0, and then we can return a 0 for at this particular point. And lastly, we probably have seen a lot of these problems before. As you can see here, the 9 and the 1, we have seen that, so that's going to be 10. And 1 and the 9 is going to be 10 as well. So basically, we're going to see multiple of these problems throughout our problem. And we're going to have to store that in a DP, because this is repeating the problems over and over again. So it's best if we store this. So we're going to set up a DP equals empty dictionary, and we're going to do a DFS of the remaining items. So if remaining is greater than less than 0, then we're going to return math.infinite for that DP, for that location. So for that amount. So if it's equal to 0, we're going to return 0 because that's our, at 0, that's what we want to return for our DP. And else if remainder is in DP, we're going to return. One way to avoid this item is if we set DP 0 to 0. So we throw 0 in here. We can remove this option here. I don't know if that's a good idea or a bad idea, but we'll see. So dp of the remainder is going to be equal to the minimum of the DFS of the remainder minus the coins plus 1. So for a number of each new coin, C in coins. And with that, we can get the minimum amount for that particular remainder. So, and then we're going to return the remainder there. And with that, we can return the DFS amount, return negative. We're going to set our answer to equal to DFS of our amount, and we're going to return -1 if answer is equal to math.infinite, else answer. So this is our first approach. This is our top-down approach, and let's see what we learned today. So it looks like it's submitted pretty well. Got through that option there, and we have solved the problem. So that is how you do the top-down approach. What is happening here is that once we get to 0, we can, let's print this out. So to make this easier for us to see what's going on and learn how this top-down approach works, and then we can use this for our bottom-up approach. This is all part of our learning. So as you can see, this top-down approach could do a DFS on 11 through 0, and then it found the answer. The minimum of this item 0 is going to be 0. Then we're going to find a -1, and we're going to find a -4, and the smallest item is a 0. So we're going to have a 0 equals 0 in this. We return that. So also we're looking at the remainder of 1. So we built that 1 out, and that's what we set for the 1. We have 1 more coin to get the 1. Then for the 1 coin, we've finished that up, and we tried for the 2 coin. The 2 coin we get the 1, and then for the 3 coin we get the 2, and 4 coin we get 2, and 5 coin we get 1, 6 coin we get 2, 7 coin we get 2, 8 coin we get 3, 9 coin we get 3, and 10 coin we get 2. And we're trying to get a 11. We're trying to get the 11th coin. And so 11th coin is going to be 1 more on top of the 10th coin, and that's why it's going to be 3. And as you can see, this last one isn't stored because we returned the amount, DFS amount, which is going to return this DP remaining. This remaining is created after we printed. So if we print this instead here, we will get a better look at it because it has been set. So DP of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As you can see, 11 here is, oh shoot, my freaking face is in the way. Here, let me remove it. Okay, so as you can see here, you start at 1, and you're creating these items here all the way down to the 11th item, and finding out what different ways of getting to 11 by running a DFS and calling these particular numbers before what has been created. So as you can see from this top-down approach, we can create a bottom-up approach with this answer, because we don't really need to drop all the way down to 1 to start at 1. We can start at 0, so we don't have to do this twice. So by doing bottom up, what we're doing is we're saving half the time. And well, I don't know if it's half the time, but a lot of the time. So anyways, I think it's half the time. So with that, we can let's sum up what we've learned today about the top-down approach, and then in the next video we're gonna go through the bottom-up approach. So in this for this particular solution, we've we have we have determined what was the base case if we go past 0. We have determined what happens if we see the DP, and we've determined how we will be getting our that particular item, that first item, and by checking the minimum between these coins, and starting at a 0, having the 0 cost 0, and going up from 1. So when you're doing a top-down approach, I think you're pretty much thinking of a bottom-up approach at this point in time. And that's you have to start thinking, okay, what's gonna happen at like 0? What's gonna happen at 1? What's gonna happen at 2? What's gonna happen at 3? Because eventually you go all the way down to, you have to go all the way down to 0. And yeah, hopefully that's the lesson here, and that this is very different from decode ways, because there are so many ways. The number of ways depends on number of coins, and that's why we chose the backtracking method rather than a linear method like decode ways, which we did previously, where we would pick one path or the other path. In this particular problem, there are many paths we can choose, and this is the line of code for that. And for this one, we see the line of code is one line of code. And so I hope this is you learned a lot from this particular problem, and there's so much more to learn, and that's why we're going to go through the bottom-up approach and the BFS method to get a more thorough understanding about this particular problem and the algorithms that we can use to solve this. So if you enjoyed this video, like and subscribe, and if you want more videos, check the link in the description below. Thank you very much, and have a good one.